Welcome. The title of this presentation is The Value of Structured Data. I'm going to talk about how structured data can improve the visibility and your search engine optimization, how it improves the articulation of your value propositions of your products and services, how it enables you to do better mobile and multi-channel publishing, how it helps to make integrations with other systems easier, and how it also enables you to easier expose and share your data with other systems and websites. I split the presentation into 3 parts. In the first part, I'm going to talk about structured data on the web in a general context. This leads on to the Semantic Web, and finally I'm going to talk about structured data in the context of CMS systems. Before I start, I just want to mention that in this talk I focused on structured data because this is an area where we differentiate ourselves from other systems, but we are also a fully fledged CMS with all the functionality you would expect, like image editing, nice interfaces for organizing your content, a rich HTML editor including the ability to edit videos, translating content, and so forth. We also support multiple languages in one site and one structure. We also support multiple sites in one installation. We also support workflows associated with the publishing and also translation. We also have a set of standard modules covering everything from e-commerce, forums, forms modules, and so on. Okay, structured data on the web is the first part. If we look at a lot of the content that is out there on the web today, it largely consists of documents. You can say that it's a web of documents. Typically you have HTML pages like these ones. They consist of images, text, and links. It's easy for us humans to understand that this article about the mobile phone sensation to the left here is a review article about the phone. We can also understand that this article below here is an article about the author, and that the picture is actually a picture of the author, and that the picture up here is actually a picture of the mobile phone, and so on. But there are some challenges with this. First of all, Google and other systems don't really understand languages, or machines in general don't really understand languages. So when they index this content, they aren't really able to distinguish this page from any other page that contains the word sensation, which was the name of the mobile phone. So if I go into Google and search for sensation, I will get all kinds of pictures of all other kinds of pages that also contains this word, because Google is basically reduced to recognizing words and letters. It can't really do this search in the context of products, which is what I was looking for. Another problem with the web of documents is that the data model and the data structure to a large extent is centered around pages that tends to be organized in hierarchies, and hierarchies work fine if you don't have too many pages, but once you start to have thousands of pages like you typically do in large e-commerce solutions, it can become really hard to organize the content. I really struggled to find these glasses, for instance, in this web shop that were located under home, personal care, and then glasses. So is there can we improve on this? We can, if we move from a web of documents and start to think more in terms of a web of data. By that I mean letting the data be the underlying structure and let the systems generate the different documents as the user is requesting the different information. An example of that is IMDb. IMDb is basically a large collection of different types of information objects like movies, actors, producers, and so on. And all this is related to each other and stored in a relational database. And there is no real tree structure at all in this website, so you can typically click, and these relations, by the way, can also be used for the navigation. So typically you can open a movie, then click on the actor, then click on the producer, and then click on other movies the producer have done, and so forth. So this kind of website would be really impossible to do with a hierarchical tree structure. I'm going to show you two examples. The first one is a website created with the WebNode CMS. It's a website that contains information about hotels all over the world, and you can search for rooms and book rooms. And this website basically contains, I think in total, almost 10 million information objects, all organized in a carefully structured system. And this can then be used for doing searches, for instance. So you typically can go into a hotel, search on the facilities, search on the prices, search on the availability, and so forth. And none of these pages are really, or the data model behind this website is not page-oriented at all, because the different hotels appear in many different contexts. Another example is a website also built with web nodes. This is the website for the Norwegian Accident Investigation Board. A lot of the page contains quite general information about the bureau, but there is also a section here where you can search for reports down here. If I go down here, you're able to make a really detailed search, since all this information is stored in a structured format. You can search based on the type of accident, the type of plane, and so forth. You can also combine this with a free text search. Once you find the report, you can open it, and you can see that the system has been able to find automatically reports related to the same type of aircraft, the same type of accident, and so forth. You can of course download the report, but you could also click here. This gives you another visualization of the different information objects related to this report. So what you see here is the report in the center, and you can see here that it's related to the location Hedmark. It's located to a type of airplane with single engine airplanes, and so forth. And I can click on, for instance, this location, and it will show me other accidents that have happened at this same location in Norway. I can then click further on another report. Then I can click on, let's say, one of the other categories. This is for lighter aircraft, less than 5,000 kilos, and it shows me all other accidents related to this this category. Okay, so those were two examples with what I mean by web of data. But there are some challenges with this. First of all, most CMS systems are to a large extent page-oriented and cannot very often be used for these kind of websites. And therefore, if you want to build these kind of websites, they tend to be custom-made and therefore quite expensive. And each solution quite often has its own data format, so it becomes difficult to integrate the data between these different websites. Typically, integrating data from Netflix, IMDb, and Rotten Tomatoes, for instance, is hard because they all organize the content in a slightly different way. So how can we overcome these problems? One way to do it is to introduce a common standard for structured data on the web. And this leads me to the second part, which is the Semantic Web. And this is really what the Semantic Web is all about. It's about providing a standard for structured data on the web that enables machines to talk to each other in a standard format, and also makes it easier for search engines to understand the contents of websites better. It's defined in Wikipedia as a web of data that enables machines to understand the semantics or the meaning of information on the web. If we look at this in the context of the development of other internet technologies, it's considered to be a major part of Web 3.0, and you typically divide it into semantic search and semantic databases. I'm going to talk a little bit about that. So semantic search is about providing additional information in existing pages, and that will enable Google, Bing and Yahoo and other search engines to understand the content of these pages better, and thereby providing more accurate search results. Semantic databases, it's about standardizing the way you store structured information and how you can exchange and provide access to that structured data through data endpoints. This of course makes it much easier to combine content from multiple websites, and also to integrate applications with contents from various websites. Semantic search first. If you go back to this first example, this review article about the mobile phone sensation could have been tagged with what is called microformat tags or microdata tags, and by doing that you provide additional information hidden in the HTML, so the actual look and feel of the article is exactly the same, but to Google they will be able to then extract information that this article is about, is a review article about the mobile phone sensation. It will be able to understand that it's linking to the producer, that the producer is linking to the reseller, that the article at the bottom left is an article about the author, and that the picture is actually a picture of the author and not the product, and so forth. And if you look more detail at this and at the resellers page, with traditional HTML without semantic tags, all you can really do with HTML is just to specify the styling of the different text elements, like h1 or image or the color of the text and so forth. But with semantic tags added to the HTML, you also specify what the different elements represent in a standard format, so that the search engine can understand where the product name is, that this is actually an article about a mobile phone, that the price is in dollars, and that the price also actually includes shipping and so forth. And with this information, Google can provide much better search results. So without any semantic tags, you're basically stuck with just showing all pages that contains the word sensation. But with semantic tags, Google is able to only show the pages that are relevant to the to mobile phones. What is showing here is basically mobile phones across various shops that contains semantic tags, and it's been able to extract the image of each website, the price of each phone, all including shipping and in the same currency, and so forth. And this makes it really easy for the user to compare data across various websites. As an example, if we search for red dresses in Google, we get in a normal search we get 191 million results. That means it found 191 million pages that contains those two words. But if we do it in the context of shopping, Google is able to filter out all the pages that are not relevant to shopping. And it's also able to provide additional filters, because there are standards for what properties are can be specified with semantic tags on these products, and typically can provide filters about silhouette, color, and so forth. And just by clicking a few of these filters, you can take down the result set from 191 million down to just 3 results. And all I did then was just to click mini dress and over $250 and in stock nearby. And this of course is valuable both to the end user and the company providing the products, The end user gets a much more relevant and accurate search results, and the company providing the products is much better able to articulate the value propositions of their specific product. And it doesn't just apply to products, it applies to recipes, for instance. You can search for tomato soup, for instance, and then and then Google is able to filter out all pages that actually are defined to contain recipes with semantic tags. And also on these pages the different ingredients have been separated from the text, and Google is able to also identify quantities and other things on all the different ingredients. So you can then use that in the filters, so you can filter on garlic, for instance, cooking time, and even calories. Google have also implemented similar functionality for events, people, and reviews. And just recently, in June this year, Bing, Yahoo, and Google all agreed on a common set of content types they will implement in their search engines, and that they will index. This is all defined in a website located at schema.org, and it basically defines more than 100 different content types relevant to most content and services you find on the web, and they're all working really hard now to implement this in their search algorithms and engines. And we in WebNotes are among the first CMS systems to actually deeply integrate with this, and this is going to be a really important factor in optimizing your search page for the search engines, because if you don't implement these semantic standards that refer to these content types in your pages, your page will basically not appear in these new searches that will soon appear on Google and Yahoo and so forth. I'm just going to show you a little example of that. This is an example site that contains various information about travel destinations in Norway. There is an area here with that contains information about Norwegian recipes. I can click here, for instance, and I get the recipe for sour cream porridge. And it looks like just any other recipe page. It's easy to understand the different ingredients and so forth. If I click here, it opens the same page seen through the Google Webmaster tool. What this tool does basically is it gives you some information about what Google is able to interpret when their robot is indexing the page. And what you can see here, it gives you a little preview of how this page will appear in the search result. And you can see here that it has recognized this as a recipe. It's been able to extract the image of the food, not the company logo, for instance. It's been able to extract the number of calories, the cooking time. And further down here, you can see that it's been able to extract the different ingredients, the quantities, and so forth. And just as a comparison, if I open another page here that contains the same recipe, this page does not contain semantic tags. So if I take this page and put this page into the search engine, or the tool, you can see that it's not even able to recognize that this is a page that contains a recipe, and it's not able to extract any information about the different ingredients and so forth. And what that means is that while this page has the same value to a human, and as the human is able to interpret all this information, Google is not. To Google, this page won't even appear in the search results, while this page will, because it contains the semantic tags that makes it appear in the recipe search. Okay. I'll now continue with the semantic databases. Semantic databases is about making it easier to integrate content from various websites and integrate data between the websites. One example of this is Wikipedia. They obviously have a large collection of articles about well, lots of things, and they have put all this content into a structured database that expose all this data through a data endpoint. Or actually, it's not a database, it's stored in what is referred to a semantic database or a triplet store. And this that means that this makes it possible for any other system that support this semantic format to integrate and all the content in Wikipedia into their own content. So it's a general purpose way to integrate and query all the structured information in Wikipedia. And I'm going to show you a little example of that. What I have here is a sample application that could be for a mobile application. What this demo is doing, it's connecting to both the data endpoints of this example site that I just shown you earlier, with different information about travel destinations in Norway. This data endpoint, by the way, is an OData endpoint. If I open that in the browser, it just returns an XML document. But this is so it's not meant to be open in the browser, but this is meant for other systems to connect to get direct access to the structured data in this website. And similarly, you can do the same thing for the DBpedia website. And once you have that, you can then build applications that connect directly to these endpoints and get direct access to the structured information in the website. So that's what this demo is doing. So if I click here now on locations, it will contact that data endpoint of this demo website and gives me a list of all the different locations in this website. Here, for instance, is Oslo. If I click on Oslo, it's able to get further information. It's showing a picture of Oslo, the text, and so on. And by the way, if you look at this website, you will find the same information here through a template. And you can see, for instance, that the picture here at the top is the same picture you see here, but of course as a different size and format. You can also see we also linked this to Wikipedia. So here it's being able to extract information about the population and so forth from Wikipedia. We can also mix this with other data endpoints, like information about events, weather information, car statistics, road traffic information, and flight information, for instance, and so on. Okay, so that was a demo of what you can do with data endpoints. And there are many other examples of companies that are using semantic technologies. One thing worth mentioning here is that all these companies are big companies. And this leads me to the third part, which is about structured data in the context of CMS systems. Because the benefits from the semantic web has so far been reserved large companies. And why is that? And the reason is that semantic web implementing semantic web standards is something that normally must be customized. There are no standardized systems that really do this well, and in particular most CMS systems don't support it, and a lot of the content on the web is built with CMS systems. So what we do with web nodes, we have created a semantic CMS that therefore enables smaller enterprises to benefit from the semantic web as well. Because conventional CMS systems have some challenges when it comes to semantic formats. Typically, you start with structured data from your internal sources in your company or external sources. Could be image asset systems, product catalogs, CRM systems, and so forth. All that data you want to publish, and you publish it through the CMS. When you do that, you lose the structured information in the data, and you basically reduce to putting the data into HTML pages. And if you want to bring some of that data into your mobiles, you do that through simplified versions of the HTML pages, and you're not really able to bring across a lot of the valuable data you have inside your company. And if you want to integrate with other systems through the CMS, you can't really do that because the structure needed to do the integration is not really present in the CMS, which tends to be largely page-oriented. So, as an effect, the CMS becomes a barrier to a lot of the valuable data you have. The way around it is, of course, to build the custom-built systems that talk directly to the structured sources and with your mobile applications or your other systems. But this is expensive, so you want to try to avoid that. And this is an area we've been working hard on, and the way we solve this is, of course, we still produce normal HTML pages consumed by desktop browsers. But unlike other systems, we put a semantic database at the heart of the CMS. This gives us much more structured data inside the CMS. This makes it possible to automatically generate additional semantic tags and inject that into the HTML. Which improves visibility in search engines, and that also implements and integrates with all the new standards that are coming now from schema.org and the content types there. We're also able to automatically provide the data endpoints that you can use to integrate with mobile applications and other applications or websites. And it's important to mention here that the alternative to data endpoints is building web services, but the difference is that data endpoints are standardized and much more general. If you want to, you can of course achieve integration through web services, but that is something that needs to be custom built and be documented, and it's something you need to build very specifically for one purpose. Data endpoints is much more general, and and easier to work with. And also data endpoints not only supports retrieving information, you could also update and write and insert content through a data endpoint. And this is what makes WebNodes different from a lot of other CMS systems. If we go back to this drawing, if we replace that page-oriented CMS system with WebNodes, you're able to bring the structured data into the CMS system. That makes it easier to provide a much richer HTML experience in the HTML pages. You can also provide better and direct integration with mobile applications through the CMS. And also integrate directly with other systems through the CMS, and that means you no longer need these custom-built expensive systems, and the CMS is no longer a barrier to the valuable structured data you have in your system. And as an example, I'm just going to show you a little demo. This is a demo showing an OData endpoint and how you can connect to an OData endpoint directly into Excel. I'm going to open Excel here. What's nice with OData is that Microsoft has brought compatibility with the OData standard directly into their Office products. And in something called Power Pivot, which is a free plugin you can download to Excel, which is available from Microsoft, you're able to connect directly to a data endpoint. And since all WebNodes websites have a OData endpoint, you're able to basically query and get all the data in a structured format into Excel. And to do that, you click here, and all you specify is a URL. This is the URL of this data endpoint I showed you earlier. If I open this in the browser, it looks like this. It's just an XML document, which then Excel can query and build queries on. And what happens now is that it gives me a list of all the different content types or entity types in the system, or in this particular website. I can then, for instance, select, let's say, all the image files. And what happens then is that Excel is able to take out information about these image files directly into Excel. This applies to all the data in the website, so whether it's users, it's submitted form data, orders in the e-commerce solutions or whatever, you can bring all that data into Excel without any programming. So here, for instance, I got a list of all the different pictures in the system. And you can then bring this data further into a pivot chart or a pivot table, or use any of the other different things you have inside the functionality you have inside Excel. And that's and I'm just going to show you how one of our client called Save the Children, this is their website. They have quite a large website, about 7 different websites in this solution, and what they have here is also an e-commerce solution, and the data in these e-commerce solutions can all be retrieved through the OData endpoint, and they use this a lot to generate statistics about their e-commerce solutions. And I'm going to show you how that looks. If I open this spreadsheet in Excel, it looks like this. What you see here is basically statistics directly from their e-commerce solution. You can see revenue per customer type, payment status, number of products per order, payment method, and so forth. All this data is what is different or important to notice here is that this data is real-time data, and this kind of spreadsheet has been created without any programming. So you could typically it is slightly advanced Excel use, but you can build it and you can send it to the client, and they will be able to open this document, and then it can then go into Excel and click refresh all. And what happens then is that Excel will automatically contact the website, the data endpoint, and update all this information, so it's all updated in real time. Okay. So to summarize, with the WebNodes CMS, or in a typical situation, you start with structured data. You bring this data into a normal. If you bring this data into a normal CMS, you lose a lot of that structure since it's largely page-oriented. But to a lot of situations, it doesn't really matter because you're just producing HTML pages. With WebNodes, you are able to bring that structured information into the CMS, and you can, of course, still produce HTML pages. But you can now automatically add semantic tags that improve search results. You can also automatically expose your data through OData endpoints and RDF Sparkle endpoints. That makes it really easy to integrate your data with mobile applications and other websites and so forth. And the net value of this is that by bringing the structured information into your CMS, you're able to get a lot more value out of your data. So to summarize, the benefits is that you improves your visibility and search engine optimization. You improve the articulation of your value proposition of your products and services by using WebNodes. You makes it easier to do mobile and multi-channel publishing. It becomes also easier to do integrations with other systems, and you're better able to expose and share your data. Thank you for listening.